Hello students, in this session we will discuss about double linked list concept. In double linked list, every node is divided into three parts as F-link are also referred as L-link, info or data and R-link parts. Okay, so here three parts are available. So L-link, data and R-link. So here data field stores information part of the element. L-link stores address of the previous node. R-link stores address of the next node of the list. Now such a view is known as double linked list format. Now observe, now it shows the diagrammatic representation of a double linked list with three nodes. Here the information parts are 10, 29 and 32. R-link part stores address of the next node and L-link stores address of the previous node. So here R-link part of the last node is filled with null pointer and L-link of the first node is filled with null pointer. Explicitly, we use two pointer variables start and end that points to beginning and ending nodes of the list. Okay. Thus, now how to define an abstract data type for double linked list. So when we observe this format, in abstract data type of double linked list, instances is a finite collection of 0 or more elements linked by pointers. The supporting operations are creation, display, insertion, deletion, count and search operations. Now observe, the basic operations on a double linked list are creating a list, traversing the list, insertion of a node into the list, deletion of a node from the list, counting number of elements, searching for an element, etc. To implement these operations, first we need to create node format. For this, here we are using self-referential structure format like type def struct list open brace int data struct list asterisk L link comma asterisk R link and curly brace. Now this entire data type is referred with a new name as node. So once this creation part completed, you are capable to create nodes like this format node asterisk start. Assume this pointer is initialized with null comma asterisk end is also initialized with null pointer. Now the first operation, creating a list. So it refers to the process of creating number of nodes based on user requirement, and we establish links in between the nodes of the list. For this, initially elements are not available in the list, hence at this stage the two pointer variables start and end are set at null pointer. Now use this implementation format node asterisk start equivalent to null comma asterisk end equivalent to null. Now based on these assumptions, now observe the algorithm format, algorithm creation. So this procedure creates a double linked list with the specified number of elements. So step 1, repeat while true is a repetition process. First read an element as x. So termination point of view, first we check whether x value is equivalent to minus 999 or not. If it is true, now return from the function. Otherwise, else. First allocate memory for a new node. So once the memory is allocated, now these three parts are available. Now data of new is filled with x, L link of new and R link of new is filled with null pointers. Now we check whether the list consists any elements or not. So if start equivalent to null, then so the first inserting node becomes start and end nodes of the list, like start equivalent to and equivalent to new. Else, if already some elements are available, now we establish links in between end node and new node as R link of end equivalent to new, L link of new equivalent to end, now end equivalent to new. And if inner comparison completed, and if outer comparison completed, and repetition process completed as and repeat. Now next operation, traversing the list. Students, you are all familiar. Traversing refers to the process of visiting every node of the list exactly once. So in case of double linked list format, it is possible to traverse in both directions, like from starting node to ending node and ending node to starting node of the list. Now observe algorithm format, algorithm display. This procedure is used to display the elements of the double linked list. So here we can traverse in forward direction as well as in backward direction. Now observe these algorithm steps. So if start equivalent to null, that means elements are not available. Hence we display a message as double linked list empty. Else, if elements are available. Now first observe the way of traversing in forward direction, like temp equivalent to start. Now repeat while temp not equivalent to null. First print the data part of temp. Now temp is shifted towards the right hand side, so temp equivalent to R link of temp. End repeat. So if you are interested to traverse in backward direction, now set the temporary variable at end pointer. Now repeat while temp not equivalent to null, write data part of temp. Now temp is shifted towards left hand side as temp equivalent to L link of temp. And repeat, repetition process completed. And if comparison completed. Now step 2, return from the function. Now observe this example. Now assume we are traversing in forward direction. Now in forward direction, now the elements are 10, 29, 32. So when we are printing in backward direction, now the elements becomes 32, 29 and 10. So in such a way, we can traverse a double linked list in forward direction as well as in backward direction. Thank you one and all.